Welcome to Kanerika's podcast, The Digital Shift. Um, Imagine trying to stop a multi-million-dollar bank fraud, but, your data is 24 hours old.
Right, and it's probably locked in 5 different departmental systems.
Exactly. So by the time your security team actually spots the anomaly, cross-references it with the customer's profile, and gets approval to freeze the account, well, the money has already crossed 3 international borders.
Yeah, it's completely gone by then.
It really is.
Yeah.
And that is not some hypothetical scenario. It is the everyday reality for most financial institutions that are still operating on legacy architecture.
Oh, absolutely. I mean, we see it all the time.
We really do. So today's deep dive is unpacking comprehensive content on Microsoft Fabric and how it is triggering a massive transformation in enterprise analytics, specifically in the financial sector.
Which is a space that desperately needs it, honestly.
Completely. And whether you are a data engineer who is just tired of building fragile pipelines or a finance executive staring down strict regulatory deadlines, or even just someone trying to make sense of the rapid shifts in enterprise tech, understanding this transition is absolutely crucial.
It really is the foundation for the next decade of finance.
To set the stage here, the content we are exploring today highlights some staggering numbers. The global data analytics market is skyrocketing from $64.75 billion in 2025 to an expected $83.79 billion in 2026.
That is a massive jump for a single year.
Right. And perhaps even more telling, 70% of Fortune 500 companies are already utilizing Microsoft Fabric or related tools as part of their modernization strategies.
What's fascinating here is that this massive market growth and rapid adoption isn't just about companies wanting to buy shiny new technology to impress their shareholders.
It's not just a PR move.
Exactly. It is a direct reaction to an operational crisis. I mean, it is a reaction to the sheer pain of fragmented data across modern enterprises. For decades, the standard approach to enterprise architecture was simply, adding more specialized tools to the stack.
Like putting Band-Aids on a broken pipe.
Precisely. You bought one tool for data ingestion, another for data warehousing, another for machine learning, and yet another for business intelligence reporting. And now that architecture is buckling under its own weight.
Before we can truly understand the impact of Microsoft Fabric, we have to understand the mess it was built to clean up. Let's look at the current state of a typical financial institution. You have your core banking platforms processing daily transactions.
Right, the absolute critical stuff.
Yeah. Then you have customer relationship management systems, your CRMs, tracking client interactions and loan applications. You have dedicated risk engines calculating market exposure.
Don't forget the general ledgers.
Oh, right. The general ledgers.
Right.
And then you have massive external data feeds coming in from places like Bloomberg or the London Stock Exchange Group. All of this data is vital, but, and here's the kicker, it's completely isolated.
And that isolation is the root of the crisis. I mean, if a bank wants a single, accurate view of a high-net-worth customer's portfolio, or if they need to generate a comprehensive regulatory metric, they have to manually pull data from all of those disparate systems.
Which takes forever.
It really was. Then comes the reconciliation phase. This involves data engineering teams writing these incredibly complex extract, transform, and load or ETL pipelines just to force these different systems to talk to each other.
And those pipelines break constantly.
Oh, all the time. It is notoriously slow, incredibly expensive, and highly prone to human error. You have teams spending weeks just trusting that the output they've stitched together is actually correct.
I always think of it like trying to cook a complex masterclass meal.
Yeah.
But your ingredients are locked in 5 different kitchens across town.
That's a good way to put it.
By the time you get the flour from kitchen A and the eggs from kitchen B, the oven in kitchen C has already gone cold.
Right, and looking at the mechanisms detailed in the content, it's actually more like translating a highly technical book into 5 different languages just so different departments can read it.
Oh, that's even worse.
Yeah, because by the time the marketing team translates their French version and the risk team translates their German version, the original meaning is completely lost. Nobody agrees on the text.
Which is exactly why boardroom meetings turn into arguments about whose spreadsheet is right, rather than actual strategy.
Exactly. That is a much more accurate way to visualize the latency and the version control nightmares, and that brings us to the core solution. The content focuses on Microsoft Fabric and its underlying architecture, specifically what is called OneLake.
OneLake. That's the game changer here.
It really is. Fabric isn't just another translation tool to add to the stack. It gives everyone in the enterprise a universal translator so they can all read the original source document simultaneously.
Let's drill down into how that actually works. Because OneLake acts as the ultimate shared data foundation. It is a single, logical data lake.
Right, the logical part is key there.
Yeah. The brilliance of the mechanism here is the complete separation of compute and storage. So all your data engineering, your warehousing, your real-time processing, and your Power BI reporting happen in this one environment without ever moving or copying the underlying data.
Which saves an unbelievable amount of time.
Completely. You aren't building those complex ETL pipelines to shuttle data from a storage bucket to an analytics engine. The analytics engine just sits directly on top of the original data file.
If we connect this to the bigger picture, the elimination of data movement is nothing short of revolutionary for data governance.
How so?
Well, every time you move or copy data in a traditional system, you introduce latency, you create a potential security vulnerability, and honestly, you rack up significant cloud egress fees.
Oh yeah, those egress fees can be brutal for large banks.
Absolutely brutal. With OneLake, a data scientist training a machine learning model and a business analyst building a Power BI dashboard are querying the exact same underlying data file at the exact same time. Financial teams are finally working from a single, mathematically unified copy of the truth.
Okay, let's unpack this. Now that everyone is reading the same book, what are financial institutions actually cooking up?
Some really impressive stuff, honestly.
Yeah, the content provides some phenomenal high-impact use cases, and I want to run through these to show the sheer breadth of what's possible when you eliminate data friction. Let's start with reporting. Look at Bank Center Credit in Kazakhstan.
Oh, that's a great example.
They serve over 3 million customers and completely replaced their fragmented reporting setup with Fabric.
And the outcomes there really demonstrate the causality of unified data. By eliminating the manual assembly line of pulling from different databases, they saved 800 staff hours per month on reporting alone.
800 hours. That is an incredible amount of reclaimed human capital. I mean, what could your team do with an extra 800 hours a month?
Right. You could actually do analysis instead of just data gathering.
Exactly. Plus, they reduced reporting errors by 40% and enabled 50% faster decision-making across the organization. That is the fundamental difference between working with data and constantly fighting with your data infrastructure.
Taking that a step further, the ability to trust your data leads directly into the second major use case, risk management and regulatory compliance.
Oh, compliance, the favorite word of every bank executive.
Yeah, but regulators today don't just want the final risk metric. They want to know exactly how you arrived at it. Under frameworks like BCBS 239, which is the global standard, forcing banks to prove exactly where their risk reporting data comes from, you need strict audit readiness.
And the content details how Fabric utilizes a Medallion architecture to achieve this level of transparency, right?
Yes, exactly.
Yeah.
The Medallion architecture.
I was looking at this, specifically the bronze, silver, and gold layers. If I understand the mechanism correctly, the bronze layer is just the raw, unmodified data dump from your source systems. But how exactly does it transition through those layers to become a finalized gold layer report for an auditor?
Well, the transition is where the governance magic happens. It structures data processing sequentially. As you noted, bronze is the raw source data, completely unmodified. This is your auditable baseline.
Okay, so nobody touches bronze.
Right, nobody touches it. Then, automated pipelines move that data to the silver layer. This is the transformation zone. It is where data is cleaned, standardized, and joined.
What kind of cleaning are we talking about here?
For example, this is where you might resolve formatting issues, handle null values, or reconcile daily transaction logs with CRM profile data.
Got it, making it actually usable.
Exactly. Finally, the refined data reaches the gold layer. This is a highly aggregated business-level data set that directly feeds your risk dashboards and regulatory reports.
So when a federal auditor knocks on the door and points to a specific exposure figure in a gold layer dashboard, your engineering team doesn't have to scramble for a week to prove the math.
No, not at all.
You can trace that exact figure directly back to the silver layer's transformation logic, right down to the raw bronze entry from the core banking system.
Every single calculation is fully traceable in real time. Now, having an auditable trail of historical data is crucial for regulators, But, well, it isn't enough if the money has already left the bank.
Right, which brings us back to our fraud example from the beginning.
Exactly. That traceability has to happen in milliseconds, which brings us to the third massive use case, real-time analytics. The content highlights the London Stock Exchange Group, or LSTEG.
Oh, their numbers are just wild.
They consolidated 30 disparate legacy systems, 1,200 data sets, and a mind-blowing 33 petabytes of data into a single governed fabric platform.
33 petabytes is almost difficult to comprehend. To put that in perspective, that is the equivalent of millions of high-definition movies streaming simultaneously.
It's a staggering volume of information.
And by getting all of that under one roof, LSEG dropped their product development timelines from years down to mere months. But actually, here is where I want to push back a little bit on the real-time processing aspect, particularly regarding the next use case, fraud detection.
Okay, let's hear.
I hear the real-time pitch, but major banks have invested hundreds of millions of dollars into overnight batch processing for fraud. And it catches a lot of bad actors. Are we saying those legacy systems are suddenly useless, or is real-time processing just for edge cases?
Well, in the context of modern financial crime, legacy batch processing is fundamentally flawed, and here is why. Think about the timeline of a modern cyber attack. Traditional fraud detection runs on overnight batch cycles, meaning it pulls all the day's transactions at 2 in the morning to scan for anomalies. By the time an alert fires the next morning, the transaction has completely settled. The bad actor has already moved the funds through 3 different cryptocurrency exchanges.
So the window for intervention hasn't just closed, it's been painted shut.
Precisely the issue. For things like sophisticated account takeovers or money laundering patterns that execute across multiple transactions in a matter of minutes, a system that checks the data once every 24 hours offers zero meaningful protection.
So what does Fabric do differently here?
This is where Fabric's data activator comes into play. It monitors transaction streams continuously as they happen. When behavioral patterns deviate from the established baseline, it catches the anomaly instantly.
Wow.
Yeah, it can trigger automated holds on the account or page operations teams in real time, long before the transaction ever clears.
It shifts fraud detection from being a post-mortem autopsy to an active automated defense mechanism. Now, managing 33 petabytes of real-time streaming data requires significantly more than just good storage capacity or a fast processor. It requires autonomous intelligence.
Definitely. Humans can't process that at scale.
And the content details an expanding architecture of AI agents that are specifically built to handle this scale.
The integration of agentic AI is where the Fabric platform moves from being merely efficient to being genuinely transformative. These aren't just simple chatbots that answer frequently asked questions.
Right, they are autonomous agents designed for highly complex domain-specific task execution. I was looking through the list of agents mentioned in the content. We have Alan, who is a legal summarizer, DocGPT for document intelligence, Carl handling data insights.
And Mike and Susan, who are particularly interesting for compliance and risk.
Let's look at the actual impact those agents have on daily operations. Take Mike, for instance. Mike is an AI quantitative proofreader, specifically built to catch arithmetic errors in massive financial models.
Which is a huge pain point.
Oh, completely. Imagine it's 2 in the morning, a team of analysts has been awake for 48 hours finalizing a merger valuation, and someone accidentally hard-codes a cell in Excel instead of using a formula. A human eye will never catch that buried in thousands of rows.
Never.
But Mike catches that multi-million-dollar rounding error instantly. Or look at Susan, an AI redactor. She autonomously scrubs sensitive, personally identifiable information, or PII, from petabytes of data sets before that data is ever exposed to a wider analytics team.
The capability of agents like Mike and Susan is incredible, but it introduces a complicating factor. We must consider how this ecosystem of agents intersects with enterprise data governance, specifically through a tool called Microsoft Purview.
Right, because AI can be risky.
Exactly. Having autonomous AI processing petabytes of financial data is a massive operational advantage, but in a highly regulated industry like banking, letting AI alter data unchecked introduces catastrophic compliance risks.
Because if an AI agent makes a hallucinated decision, or alters a data set in a way that violates privacy laws, the regulators don't care that a bot did it. They hold the bank's executive board entirely accountable.
And that accountability is why Microsoft Purview is integrated directly into the foundation of Fabric. While the AI agents do the heavy lifting of data processing, mathematical proofreading, and summarization, Purview sits underneath them, automatically tracking the data lineage.
So it's essentially acting as a guardrail.
Yes, a very strict guardrail. It guarantees that security policies and strict governance frameworks, like California's CCPA or Europe's GDPR compliance, are automatically and uniformly enforced. If an AI agent attempts to pull data that violates a privacy tag, Purview blocks the action. The agents are entirely constrained and monitored by the governance layer.
This technology sounds like absolute magic. I mean, a unified data lake acting as a universal translator, real-time anomaly detection, stopping fraud in its tracks, autonomous AI agents doing the heavy analytical lifting, all wrapped in automated, foolproof compliance.
A great pitch, right?
It is. But let's ground this in reality for a moment. How does an enterprise actually get their legacy systems into this new environment without breaking everything? You can't just flip a switch on a decades-old core banking system.
That transition is the most critical question for any chief information officer or finance executive listening today. The migration itself is where most digital modernization efforts fail spectacularly.
And this is exactly where we at Kanerika step in.
Yes, it is.
We see this challenge every single day with our enterprise clients. The theory of Microsoft Fabric is beautiful, but the practical reality of migrating is incredibly complex.
A very common and very dangerous misconception is that an enterprise can simply execute a lift and shift.
Oh, the classic lift and shift.
Right. Organizations think they can take their old architecture from legacy platforms like Informatica, aging SQL servers, or heavily customized Tableau environments and just copy-paste it into Fabric. That approach never works.
Never. Because you aren't just moving raw tables of data. You are trying to move decades of deeply embedded business logic. Take something like SS Cubes. These are legacy multi-dimensional databases that companies have spent 15 years writing custom rules for.
Exactly.
If you try to brute force a lift and shift of that environment, you lose the intricate rules that govern data correctness. You end up with a shiny new, ultra-fast platform that is full of corrupted, mathematically inaccurate analytics.
To solve that exact problem, our strategy focuses heavily on Kanerika's FLIP platform migration accelerator. It fundamentally changes the mechanics of modernization.
How does it actually work under the hood?
Well, instead of relying on manual, error-prone recoding by a massive team of developers, the FLIP platform acts essentially as an intelligent compiler. It automatically parses the old SQL code, untangles the legacy pipelines, and translates those historical business rules into Fabric-native equivalents.
So we ensure that the intricate business logic preserved in your old SS Cubes or Informatica workflows is accurately translated. But the crucial step is what happens next.
The validation phase.
Yes. We at Kanerika extensively validate that translated logic. We run parallel tests to confirm absolute output parity between the old system and the new Fabric environment before the final cutover ever happens.
Because you can't afford to be wrong.
Exactly. By automating the code conversion and strictly validating the mathematical outputs, we are entirely de-risking the migration process for financial institutions. You no longer have to choose between modernizing your architecture and keeping the operational lights on.
That level of risk mitigation is essential. When you are dealing with Tier 1 financial data, a migration failure isn't just an IT headache that requires a weekend of overtime. It's a severe regulatory breach and a permanent hit to market trust.
So let's look at the other side of that mountain. Once Kanerika helps a client successfully migrate, validate their logic, and get up and running on this unified platform, what is the actual financial payoff?
It's significant.
Here's where it gets really interesting. The content shares a forced or total economic impact study, and the numbers are jaw-dropping.
The financial metrics validate the effort entirely.
We are looking at a 379% return on investment over 3 years, a net present value of $9.79 million, and $779,000 saved just in pure infrastructure costs alone.
And that's just the baseline.
The content also notes Microsoft's own internal finance teams, who consolidated their global operations onto Fabric. They started delivering actionable insights 60% faster, while simultaneously cutting their data generation costs by 50%.
To understand the causality behind why these savings are so drastic, we have to look past the surface-level tech efficiency. Yes, cloud compute costs might drop because OneLake is highly optimized, but the real bottom-line impact comes from structural elimination.
Right, getting rid of the bloat.
Exactly. First, you are drastically reducing the software licensing fees of maintaining 5 separate disjointed tools. You no longer need a multi-million-dollar contract for an independent data warehouse, another contract for an ingestion tool, and yet another for a separate reporting suite. Fabric consolidates all of that.
That immediately slashes operational overhead right off the balance sheet.
Second, you are entirely eliminating those thousands of manual reconciliation hours we discussed earlier regarding the ETL pipelines. Time is money, and removing the manual engineering required to constantly shuffle data frees up your highly paid workforce to do actual analysis.
Which is what you hired them for in the first place.
Right. And third, the AI co-pilots built into Fabric give business analysts a massive 20% output boost. They aren't waiting 3 weeks for a data engineering team to write complex SQL queries anymore. They are querying the OneLake data directly in plain conversational English. You are doing significantly more advanced analytical work with the exact same headcount.
It is a complete paradigm shift in operational efficiency. And it's important to recognize that the massive ROI we are seeing in the finance sector is acting as a blueprint for the entire global economy.
Very true.
While banking is the tip of the spear because of its extreme data density and severe regulatory pressure, this framework isn't just for finance.
The underlying logic of OneLake unifying scattered data to drive autonomous AI is universally applicable regardless of the product being sold. The content clearly shows this architecture is already transforming healthcare by modernizing fragmented patient systems and automating diagnostic workflows.
And manufacturing, too.
Yeah, it's revolutionizing manufacturing by boosting production speed and reducing factory floor downtime through AI-driven predictive maintenance.
It's impacting retail by digitizing inventory operations and automating supply chain tasks to build stronger real-time customer connections. And in logistics, it's modernizing fleet operations for significantly faster decision-making and dynamic route forecasting.
The specific key performance indicators change depending on the industry, but the fundamental mechanical solution remains exactly the same.
Stop moving your data through brittle pipelines and start layering unified intelligence directly on top of it.
Exactly. It is a horizontal technological shift that is driving deep vertical-specific transformations across the global market.
As a Microsoft Solutions partner for data and AI, we at Kanerika build these Microsoft for Financial Services platforms end-to-end. We handle everything from the initial data integration and those complex FLIP platform migrations, all the way to establishing the Purview governance frameworks and deploying custom, heavily regulated machine learning models on Azure and Fabric.
We make sure the system isn't just built, but built right, with parity and compliance guaranteed.
Ultimately, it is about delivering a governed, scalable foundation that actually realizes the specific ROI the technology promises on paper.
So what does this all mean for you?
That's the big question. If you take one overarching theme away from today's deep dive, it should be this. The era of siloed data, of manual spreadsheet reporting, of accepting data latency as an unavoidable cost of doing business, that era is officially over.
It's done.
Unified, AI-driven platforms like Microsoft Fabric are no longer just a competitive advantage for early adopters. They are the new baseline for survival in the modern enterprise space.
The technology has matured to the point where structural data friction is no longer a valid excuse for operational failure. But this raises an important question, one that isn't explicitly detailed in the content, but feels entirely inevitable given the trajectory we've discussed today.
Okay, what are you thinking?
If platforms like Fabric and these autonomous AI agents eventually completely automate the data gathering, the reconciliation, the mathematical proofreading, and the regulatory reporting, what happens to the humans?
Oh, yeah.
Does the future role of a financial professional shift away from being a number cruncher entirely?
Think about the implications of that. If the machine guarantees the numbers are perfect in real time, the human value isn't in calculating the data anymore. Will financial analysts essentially become behavioral psychologists?
It's a real possibility.
If they spend zero time assembling data pipelines, will they spend 100% of their time predicting how human markets, emotional clients, and irrational competitors will react to the perfect insights they now have at their fingertips? It changes the very definition of what it means to work in finance.
It shifts the entire profession from hindsight data management to foresight behavioral strategy.
That is a profound shift to truly mull over as you look at your own data pipelines and the future of your teams. Thank you for joining us on The Digital Shift.